Okay. So what is happening here, especially on innovation and innovation, we targeted very much at the IHL. People like the body. Some of the students have got a bit money for the final project. We find that the project further develop the product, Dr. Neo Aeronautics will help me. So it's a good opportunity to become. So I hope that this afternoon here, spend 2 hours last year, give some learning in this house. Okay, I think I'm not sure you all have known the E-Model idea is what as a religious specialist of spending and think all of you. Most of you have met me, okay, in case some of you are new. And together my team, I have Calvary and Aiden. Both of them are teachers in London for spending. So they come to London to help me to run events, something like this. And together with them, we go for do consultation with schools. Okay, then we set the Serena, which is over here. I also see the EBA and better report. James is now depending on attention with special service. So you can't be with us, okay? Indian law is occupied with South Africa. So both he's not with us also. So James and Indian law, both of them are supporting the schools of FOP future. Okay, I think you get to see them in the email. Okay, so what's the objective of this COP over here? We find that why I want to bring over here, we want to have this learning journey, this information that was later how people share with you all. And see some of it. As I mentioned, over here this is a very good thing. Every time we talk innovation. What is really innovation? This is something innovation in action. In a place like this, you see that Dr. Neo and his team, feel that by of course, there are some other things behind the show. Okay. And also another objective is actually to network together the whole FOD community, gather together, share our experience of what we can do, whether in terms of lesson, in terms of prototyping or anything. Okay. Of course, later on we'll bring out this idea of what we call EC. Okay. So what is our program today is we'll get Dr. Neo and Steve to share with us the first segment of this thing. Then after that, we will gather, we will discuss a little bit about the sharing of some workshops and learning journey, then talk about campus sharing and some of the schools, then followed by the talk of the mission of the COP. So everything should wrap up. There's some good discussion, so if everything on track, we should finish by 4:30. Okay? So, okay, I've been with Dr. Neo for the past 2 years. I've been doing airport and astro project together. Okay? So that project is actually to reach out to people in terms of STEM, and at the same time, that's where this step was set up. So I think before much ado, I think we address all.
Right. Thank you.
Okay, so welcome. Apologies, I can't move around. I got a slip disc, so his part is actually quite painful. So I'm not going to stand too long and speak to you, but you can always ask me any questions. So I will let my engineer Damien to actually talk about the design. So the original concept of a flying car, obviously now you all know, like DPM and everybody announced 2024. There is a you can have that flying car, right? You can ride. I think it will cost you $500 per ride, lah. So yeah. So I think conceptually, when we are talking about flying car, or in this case using drone to propel the flying machine, It's how we bring technology together. So originally, it is very, very difficult. We always have the concept, we always have the dream. And here what we're trying to get is get kids to dream a little bit more. But dream is also must back up by science. So I think that's the part that science has already comes together with the engineering to make things possible. Now we just the innovation, how to build it, and the commercialization part, how to make money from it, right? So I'm more into the innovation and entrepreneurship part, right? How to come up with useful ideas, and then commercialize it. Okay. So any questions you want to ask? We have briefed them already, right? We have briefed them the fire exit, right? That's straight away. Yeah. Yeah. Other stuff is that we have drinks, we have ice walk, we have a pantry there. Anytime, please go ahead. All right. That's all right. Yeah. I think I'll introduce Damien. Damien can stick with me for designing the first generation to the second generation. The second generation is this one, which is we display in the air show in 2020. The last, not the last, the previous air show, 2020. This is 2022, and we are now working on designing the third generation. Okay, so first generation is really concept testing. Second generation is aesthetics looking. Third generation is supposed to fly. Okay, so I mean they all fly, but supposed to go a real flight test. Okay, so I ask Damien to carry on. He probably will walk around and tell you what it is. Okay.
Hi, I'm Damien. I'm the engineer that developed the flying car. So for when Prof Neo approached me, I was still in I just graduated from SIT. So he approached me and my team. So is to develop the flying car. So when we got an idea, we were very excited. But the thing is, it's not about just designing a very large drone. We have to like encompass the safety of like fitting a human inside, factoring safety factor and all those type of stuff. And then this time around, we have to adhere to a specific guideline, which is the Part 103 from FAA. So this certification actually allow us to fly this as an ultralight in the US. Yeah, sadly we can't do it here locally, but this craft was developed to fly in the USA. Yeah, so you can see from the design, it's very compact. So it fits into a 3x3 meter parking lot in the US. Yeah, so majority of the person that have like a house garage, they can actually fit this craft into it. Yeah. So the difficulty designing with this strict regulation is we have to fix the weight of the craft to be 115 kilograms. Yeah, because under the ultralight regulation, the curb weight or the overall weight of the craft cannot exceed 115 kg. Yeah, but for us it's an disadvantage because that particular set of regulations is for those petrol generated aircraft. Yeah, fuel, all these are excluded out of the weight, but for us we have to, the battery weight, all this has to be part of 115 kg. Yeah, so we had to crack our brains a lot to come out and use like composite designs, lightweight lithium battery, and very efficient propulsion system. Yeah, so it took us about for the first craft, it took us about 6 months to design the craft from scratch, and then another 3 months to do the manufacturing. Yeah, so that one we test flown it really. Then when we move on to the second craft, this one we were pushing it for the airshow display. So the design and the manufacturing took us about 6 months just to come out with this craft. Although there's a lot of hiccups here and there, but we actually managed to get it work. So this system actually has 8 motors. So they are coaxial driven, and we will say is 100% redundant. So it's designed to fly with 4, but the additional 4 is for redundancy, and at the same time it also boosts efficiency. Yeah. Then for flight controller, it has 3 flight computers on board. So it's very similar to how we design the aircraft itself. Yeah, so safety, all this is really the #1 priority. Yeah. So now is the phase where we're going to design the third craft ready. So this time around, the third craft, we will be bringing it to the US for actual FAA flight certification. Yeah, so design-wise will be similar, but we will move on, we will go to a more aesthetic and practical type of design. Yeah, because this time around, what we want is because for a lot of people, when they look at this craft, it feels very, when they go in, it looks very like a F1 type of car. It's very enclosed inside. Yeah. So for the future one, what we want to do is much more like an open cockpit type of design. Yeah, because this craft is not designed to fly very high. It's up to 10 to 15 meters above the ground. Yeah, so we want the users, all these, when they fly, to experience really in the air rather than being in an enclosed area. Yeah, so we hope that the third one would actually bring us even further and eventually get the FAA certification for us to deploy and fly in the US. Yeah, thank you. Maybe your turn around, I can use the craft as an example to show you. Yeah.
Originally, it was placed there. But because he said a lot of people come, so we
Yeah. So these are the main propellers that actually propel the craft. Yeah. So all these are customized to our specific design requirements. So each arm, right, you see there are a pair of it. So it's a coaxial system, and then there are four pairs of coaxial system. Yeah. So the way when we do the power delivery system, there will never be a case where both on one side will fail. Even if it does, only one out of two would fail. Yeah. And then also for the battery system, is a hot swappable system. So all the batteries, all these are all stored in like a hot swappable box. So after you fly, you land, all you need to do is just to pick up another set of four and then put it in to continue flying. Yeah, you don't have to like mess around with the long wires, those type of stuff. Yeah.
It's a very different concept from the EV, right? Because EV, you have a specific charging station, EMS charging station all over the place. So when you think through, we cannot have charging station all over the place. And because the battery current technology doesn't allow us to fly very long duration. So probably you're talking of 15 to 20 minutes. You need to have a charge already. This is the current technology. And therefore, you have to think carefully how to recharge the craft, right? So the idea is not to plug in and then wait for 2 hours. Okay, the idea is that using the, I say, 7-Eleven concept. So if every places has battery, what is called replacement or swapping station. So you go to 7-Eleven, you land, you take out, plug in, you fly off. So you buy back, you buy power basically. But that's the reason why it's designed to land on one car park lot. Land on one car park, you move on, then you move on. So it's like GSM, right? The whole idea of why satellite can reach out big place, right? Because you must put a satellite up. But GSM is ground station, but you can sort of pass over to another ground station. And that's the concept of distributed power charging station. Okay, and I think that's the reason why it's designed is hot swappable, so that when you land, you change, you continue, so you can continue your journey.
Other than that will be the designing of this chassis. So this chassis is made out of carbon fiber composite. Yeah. So the target weight of this chassis, right, is about less than 25 kilograms. Yeah. Given the fact that it has to support the weight of all the mechanical structures and also the human pilot, as well as the impact resistance when there's hard landing. Yeah. So all these we use different components, such as titanium, grade 7 or grade 7000 series aluminum or 6000 series aluminum. So we played with a round of different material and their properties to actually get the sweet spot in terms of weight for the building of this craft. Yeah. Other than that, a lot will be on the flight system itself. For this one, there is a downward facing LiDAR. So what it does is, because we are only flying at 15 meters above the ground at all times, So our downward facing LiDAR actually enables us to do what we call a terrain hugging flight. Yeah, so regardless of the terrain, the craft would always keep itself 50 meters above the ground. Yeah, so even there is a slope or upward hill, right? When you are flying the craft in a particular direction, it will always be 15 meters above the closest object on the ground. Yeah, so these are some of the safety features that we have. Then in terms of the how easy is it to fly? So it's very similar to flying like a DJI type of drone now. So when you want to take off, you hit the button, you will take off to a predetermined height, let's say 50 meters. So once you're at that height, even if you are hands-free, the craft will just hover in the position. Yeah. So you can input in simple maneuvers like going forward, left, right, and all those other stuff, and the craft will do it. So in the event that there's an emergency or what, the moment you let go of the controls, right, the craft will just come to a halt and stay at the position. So you're never going to drift around or trying to, you don't have to spend time fighting the craft. So the flying, all these are done automatically via the computer. Yeah. So, but in the future, the system is more than capable of doing autonomous flight. But because it's Part 103, we are unable to do the autonomous part. But we can make the flying semi-autonomous, where most of the complex, like the complex maneuver, all these are all pre-programmed in the craft. All the user need to do is just input in where the direction he or she wants to go, and then the craft will handle from there. Yeah. So when it comes to landing, all this is also all automatically done. So when the user fly to the spot that he or she wants, hit the button, the craft will land by itself safely. Yeah, because in traditional flying, taking off and landing is one of the hardest for anyone. Actually, landing is one of the hardest. It's technically what they call a control crash. Yeah. So what we do with all these intelligent system now is we can automate, set like certain safe parameters, and then when the user execute, it's very safe. And it's very easy to use. So when we did our research, all this, it takes about less than 2 hours to train someone to fly this craft on the simulator. Yeah, so it's we try to make it as simple as it is so that almost everyone is able to fly it and experience flying. Yeah, it's not as complex as it looks. Yeah. Think. Okay.
Any questions? So when we are researching and designing this craft, right, we're looking at the Singapore law, right? In Singapore, there is no concept of ultralight, no legal definition of ultralight. It's just planes, aeroplanes, and so I'm a pilot, so I know how to fly a plane. But since there's no ultralight, even for us, when we want to fly ultralight, we can't fly in Singapore. So both of us, when the whole team of engineers go to Malacca just to fly ultralight, to get ourselves familiar, and we fly in Malacca, and we have, I think, for 800 feet, right, or 1,000 feet. Yeah, about 1,000 feet. We take off Malacca runway, take off just to try out the concept. Only 50 minutes. 50 minutes, you can take the whole takeoff and landing. So that's actually very long for non-flyer. Yeah. For pilot like me, we fly at least 1 hour. All right. So 50 minutes is actually good enough for non-flyer. So the idea is to have non-fly people who are not trained to be able to fly easily. But Singapore, you need a license. Basically, it's not easy. So this is designed for America market. All right. So where a person who has no flying license can actually use this and fly. So we'll start probably with the tourist market. Yeah. Okay. Any questions? Yeah.
Charging the battery for a single pack is about an hour. Yeah. With the current technology now, the battery capacity actually still supersedes the charging capability. So to charge such a big battery, it still takes a while. Yeah, but it's not as long as an EV car. Yeah.
So the commercialization concept is that you have a battery charging point. So you land and you just swap, and then they let the guys who are providing the service to charge the battery. So there will be extra sets. I think if our car is designed that way, it's much more simpler, rather than park there and then the car got to be there for the charging time. Okay, so there are different concepts.
How fast can it go in 15 minutes?
How far? Okay.
Okay, for under Part 103, the maximum speed that we are allowed to fly is about 100 kilometers per hour. Yeah, so this is okay, but it's actually quite slow compared to other craft when you're in the air. On the ground, it's fast. But when you're in the air, 100 km per hour is not that fast. So 15 minutes is good around to fly around the airport or to maybe from a city to a small city type of flight. Yeah.
Or we do a mapping from, let's say, like the time we base in Loyang. So we do a mapping how far we can fly. So we can reach Bintam lah. So we can reach Johor Bahru. So no problem. Yeah. Actually, very slow already, because when we fly my Cessna, my average speed is 86 knots, nautical miles per hour. So you can see it's like, this is super slow. But it's not for people with flying experience, so it's okay. So the idea is to slowly fly and enjoy the scene, not to fly so fast and you don't know what's happening, right? Yeah. What's the safety level? Yeah. Yeah. So I think before he go into the technical thing, let me talk about this. Got people say, what happened if it crash? Then I will say, what is the situation that it crashed? You cannot just say, what happened if it crashed, right? So we do hazard analysis, we do safety design. Redundancy, I leave it to him, but actually don't fly very high, right? So we are like 15 feet, and then what are the possible things that can happen? The possible things that happen is battery flat lah. Battery flat, you'll just fall down, right? But we have batteries, four set of batteries powering different propellers. So you cannot say battery die, all die. There's no such thing. Okay, so therefore there's a safety probability of all the battery dies all at one time is almost not there, right? Secondly, you 8 props, right? 8 propeller. You only need 4 propeller to descend. So you already reduce. Then people say, wow, bird strike. But bird strike is really dangerous for what? Jet engine, not for propeller. Why? Because you come, I kill you. Right? Jet engine is sucked inside, then the engine gone. It's a different concept. So a lot of people just don't understand. So you can calculate the probability is that the bird, this thing, jet, why bird gets sucked into jet engine is because jet flies so fast, the bird cannot react. Here, you don't fly too fast, the bird fly, here the sound only fly away already. Correct. So other safety things that we haven't put in, but possibility some we're exploring what jet airbag kind of concept. When that landing, we explore also using parachute. That means behind put a rocket, shoot out a parachute, right? No, you cannot just parachute like that. Fighter jet can parachute up because the seat behind is actually a rocket. But I don't think anybody want a rocket inside here, which actually is not very expensive, to be frank. About 10K, you can put a rocket there already. But you got to shoot that guy up, and then the propeller, the parachute then can open. Okay? Because if you just on the ground, you just shoot up, you will not capture the air, so it won't make sense. So that, and there's at least 1,000 feet before the parachute can properly open. So too low also doesn't make sense. So we are not flying very high, we are not very high speed, and we have a lot of redundancy built in. Yeah. So we've got to trade off lah. Oh, anything else?
I think for what Prof say is we have looked through many types of situation. The worst case of the worst case would be when there is a total power outage. Then the craft dropped from the sky. So that's what a lot of people would foresee what if the craft crashed. Yeah. So let's case for the worst case is we are flying about 10 to 15 meters in the air. Then the propeller died, the craft dropped from the sky. Yeah. So the way we design the chassis and the landing gear is exactly the same as how a helicopter would do it. Yeah. So little background, when they design helicopter with the landing skids or wheels, so they have to do an impact test or shock test to see given a specific drop height, free fall, the chassis or the landing gear needs to sustain some form of force or weight without any serious deformation. Yeah. So for us, we did exactly the same. So although the landing gear you see are very stubby and very short, they are actually made of grade 5 titanium. They are very strong but yet flexible. So in the event that we drop this given from the helicopter spec, I think was about 5 to 10 feet. So the moment you drop it, the landing gear is able to flex and absorb the weight, but at the same time does not deform or affect anything on the chassis. Yeah. So these are some of the tests that we have to encompass. So we cannot just Part 103, we follow an aircraft, then we design everything based off an aircraft. Because the flying style of this type of VTOL is very similar to a helicopter. So we still have to see how a helicopter landing gear is being tested. Yeah, so those are the different type of testing that we do to ensure that even there is a total power failure, when the craft drop, the chassis, all these are able to handle. Yeah. Of course, when you are dropping at the height, the arms, all these would be damaged. But the most important part will be the chassis where the person is inside is still one. Yeah. Yeah. I think would be, maybe I share with you a little bit on how we do the wiring for the propulsion system. So there are a total of 4 packs of battery and there are 4 pairs of motor. So let's say the first pack of battery, they will power the upper of the front two. The second pack will power the bottom of the front. Same goes for the back. So in the event that when I pull one of the battery out, there will never be a case where a pair would actually stop. One of each will still be working. Yeah. Of course, if both the front doesn't work, the whole craft will just flip and drop. It's exactly the same as an aircraft when the wings break. The aircraft just drop, or the helicopter blade breaks. Yeah, so those are things that people don't really look into. Yeah, because when you talk to them about UAVs, all this, it's still not mature in the society. So whenever people hear about this type of craft, they always think that when the propellers drop or what, they will just drop. Yeah, but when we look deeper into the aviation industry, actually aircraft wing brake, the helicopter propeller brake, all these are also questions that people pose and ask when they first came out. Yeah, correct. So these are the things that we have to learn and how to share with the others. Yeah.
2 questions. What's the name of this prototype, and what is the weight limit of the? It's not considered pilot, right? Whoever uses the flying car.
Yeah. The name is Crimson. Yeah. The model is S8 so it's for the 8.
Okay, so the name is Crimson. You know Crimson, the bird. Yes, supposed to be unofficial Singapore national bird. And then the crimson bird has red color and white color, so that's why it's red. And the what else?
The weight.
The weight limit.
So for this model onwards, the previous one was lower. So for the one that we are actually marketing, the weight limit is about 100 kg. Yeah. So it's 115 kg curb weight with 100 kg person payload. So the total flying weight is almost 215 kg like that. Yeah.
Yeah, the maximum weight of the craft 115. This is according to the ultra lightweight. Yeah, so exceed 115 needs a pilot license really. Yeah. Uh-huh. Everyday use.
You see, when we fly these, we have to wear a helmet with ear protection, same as those you fly on like a helicopter. Yeah. So when we are flying these, we do need to wear helmet with ear protection because after all, it's a vehicle designed to lift human. So same as an aircraft, helicopter, this sort of thing, there is still a sound. So the sound is still there. Yeah. This one is, yes, correct. It's slightly, it's not as, it's loud, but compared to a helicopter, it's slightly lower pitch. This type of craft is slightly, the frequency is much higher. Yeah, but the amount of air that is being pushed through by the propulsion system is still very large. That's why the sound is still there. Yeah, correct.
You can't expect like commercial airliner, right? You got to see like those propeller plane, which has not much of a vibration installation, noise installation. So you have to wear your headset, the noise cancelling headset. But if you are looking at how loud when it's up in the air, I think when it's up in the air, it's not that loud. You are like the normal craft like that. Yeah.
For the pilot itself, with ear protection is okay. Whereas on the ground, is when you are flying past is when we did the calculation on the sound, is identical to a big truck driving past. Yeah, correct. For this one, the reason why would be the time we did explore mounting the propellers on top. Yeah, but because those craft, we are unable to hit the minimum weight requirement of 115 if we shift the entire thing on top, because they will call for an additional structure. Yeah, because the initial one, the very first idea that we came, we wanted to put a wing. Yeah, so it's more like a VTOL type of craft where you can transit. But when the moment you add in the wing structure, all these, and the beam, the weight immediately exceed 115. That's why when we, another thing would be the battery itself has to be within 115 kg. So like if I do a breakdown on the weight analysis, the frame is about 20 to 25 kg. The propulsion system is additional close to 50 kg already. The remaining 70 something kg is on batteries. Yeah, so this craft almost half the weight is batteries. Yeah, whereas if you compare to like gasoline powered, their fuel is actually not inclusive in the 115 kg. It's an additional count. But for us, it does not, FAA do not allow that. It has to be still within the 115 kg. So we have to work around and make sure that the weight itself does not exceed 115 kg with all the structures that you want to put. Although parachute, airbags, all these are safety equipment, they do allow us to exclude it from the 115 kg. Yeah, that's why when we designed this, I think the best way was to design a monocoque chassis that's able to handle the strength and the weight that is being generated from the arms. The moment we shift it up to the top, the additional structure that we need to actually support all this mechanism is much more heavy than we expected. Yeah.
So the design constraints is once you are low, then you got to prevent the guy from putting his hand out, right? And that's why you see the thing is very covering, so that you force yourself to be inside, your hands. we thought over here about the show.
The first craft we actually have, so it's more like a bubble cockpit. Yeah, but the moment we come up with a shield, you will start to lose certain type of structure here. And then the feedback will be that they are too close to the propeller, then they are scared. That's why this design onwards, we decided to enclose it. So technically it feels more like a roadster type of feel because you are flying for 15 to 20 minutes. You want to experience the air. Yeah, correct. I mean, it is more exciting, whereas if you trap yourself all the way inside for a short while, the experience is much more different. Yeah. Yeah. Correct. Okay. Okay. Understand. Okay. Okay. Yeah. Correct. The roll cage type of stuff, yeah. Correct. Because for this design, we have a roll cage to prevent the thing from tipping over. Yeah. Correct. It's like a halo type of design lah. Yeah. Because this craft we are flying so slow and so low, by adding all these restriction into it, from our testing all this, we feel like we are deleting a lot of experiences away from flying an ultralight. Yeah. Because when we fly the ultralight in Malacca, it's a pure open cockpit. Yeah. So when you are diving down all these, the amount of air rushing to your face, sometimes you feel a bit hard to breathe. Yeah. So those are the experience that we are trying to get. Yeah. Correct.
No. Yeah, lightning you cannot fly. Yeah.
Up to Cat 1, this one.
But
yeah.
actually it's the same as if you are flying, let's say, a Cessna, right? You are flying what we call VMC, visual. So if it's at night, you also can't fly. So you see, everything evolved, right? Because we are like, we just compare it to a plane. No, we just cannot compare it to a plane. You got to compare it to a new kind of transport mechanism, and you design slowly add features, right? I mean, we show this, and then a helicopter pilot comes and says, this is very unsafe. Then I was like, yeah. Then the next thing he says, where's the engine? Where got engine? No engine here. So you see, they are stuck in their thing, right? The world lah. So you got to start with something very simple. Make sure you fly, then you improve lah. It's like the Wright's brother, the very first craft, get it fly first. Yeah. It is. I tell you, it's very interesting. Some of my engineers, they fly simulator. So one day they call me and say, "Hey, can you bring me up?" I say, "Sure. Let's go to Seletar, take a plane up, and then I just get an instructor. I'm not instructor grade, so I get an instructor. Sit there and he fly, and he can fly. The only thing that he's unfamiliar with is actually on the ground. Actually, in the air he can fly, right? Because he gets so used to the simulator, he can fly. On the ground, he cannot get used, because when you are doing simulator, there's no such thing called using your leg to control. And in aircraft, there's no so-called turn left and right. Turning left and right is using your legs to control. And that's why on the ground, he very gabra, but on the air, he can fly. So it's a matter of simulator flying, right? Training. Nowadays, goes like this. The interesting thing is you ask people, have you fly drone before? Most of them say yes. How is it? You want to go up? Go up long and stay there. This is what it is. And that's the reason why we say we take 1 to half an hour, maybe just to train people, just to fly. Just imagine this. You take a drone controller, you fly this, and then you just walk inside, sit inside and fly. That's the concept. Yeah, because it's identical. Half an hour to 1 hour training should be enough. Okay? Oh, yeah. Mass market. Oh, Singapore context. Mass market. I think personally 5 years later, not so soon. Singapore too much constraints because of our environment, right? You see. So Volocopter say, okay, we are going to commercialize 2024, right? So if you look at Volocopter design, it is registered as what? What kind of craft, right? Likely, it's registered as a helicopter, which means you need a pilot to be sit beside you. So how do you mass commercialize this thing? You need to go for flying license. I don't even have a helicopter license, which is very different in principles in flying compared to aeroplane flying. Secondly, in Singapore, we are so congested and it will create so much sound that you are not allowed to enter any housing estates, right? It's unlikely, so it won't happen. That's what I see. 10 years also won't happen. So the only way you can fly is Marina Bay inside or Bedok Jetty go out, come back Marina Bay Jetty or Sentosa Jetty land. The way I look at it is you are allowed to fly over places where there is no human below, likely, and it will be fixed. You will not be just go anywhere because, again, if you go to the sea, yeah, you also have all the ships, our ships, all the quite high one, right? So I think it's difficult. I think it will be fixed route, and just yeah, it's just like the flyer, you go there and you go one round, and that's about it. I don't. Maybe the concept of to the Batam and Bintam golf course or whatever, drop by there. I think fixed route may be possible, but I think beyond that, I still don't think it will be a very mass thing in Singapore. Yeah.
Considering you foresee this to be like a very common vehicle in the future where you can just land easily, but I'm not sure how it's going to be landing now. Is it like plane, doing some runway, or you foresee it's really easy to just land in such that those perhaps characteristics of this first, like they have a big garage or land, then you can just land there.
Yeah. To answer your question, he can answer in details. To answer your question, this one you can call Crimson 35B. We're going to buy the F-35B, which is like that. You can call the Singapore version. This is like that. Yeah. I want to go detail how it take off.
The takeoff and landing is fully automated. Yeah, so once you reach your desired area, you just hit the land button, the craft will just drop by itself. Yeah, correct. But at the same time, you detect obstacle. If there are obstacle, bushes, all these nearby, they will prompt you and stop. Yeah, correct. So it's still up to the user to determine where is safe enough to land. Yeah, so the system is just like the car safety system. When you reverse in, all the sensors will show you. If you still continue, then it's on you. Yeah, those type of stuff, correct.
So unlike helicopters, you have all this pool, right, where you lift up and down with the pitch and these things. This, for you to do it's again away from that concept. We don't expect people to be able to fly it so well that it can land so nicely, so it's fully automated. It's all software control. So you just need to say, I want to land, and then they will bring you down. Same as I'm going to bring my drone to this stage, and I just show my intention, and you reach a state, and it's just hover. Where you don't need to control the hover, the software will control for you. Yeah. So if you look at the latest generation of aircraft, most of times it's just an indication of intention, right? The software will mostly control all the surfaces. Yeah. So it's up and down, very simple. Okay. Originally, 2020 when we finished the air show, the original idea when I collaborate with Science Center is to bring the craft to your schools and then park there, and then the students can take picture, can do some, I would say, mini project or whatever design, just to fire their creativity. So for the last 2 years, we are unable to do that. Going forward, we still don't know whether we can do that. But this craft, we're going to design new one, so this craft is going to stay here. And if your school want to excite your students, want to go to assembly, if the assemblies can talk, we can park there for 1 week for you. You just pay the delivery fees, truck it there and park it there, so we are fine. Yeah. Yeah. We actually do live stream because we see for the last 2 years we've been doing streaming. Yeah, if you see our YouTube channel, we've been doing streaming for a whole series of innovators and entrepreneurs. Because we cannot go into school, so we've been doing all the streamings. So yeah, if you want to, we can actually do that. Yeah. We even stream the astronaut in. Yeah, that's our intention. But to carry 2 passengers means what do you see?
You need something like a sports license, really.
Yeah.
Yeah. So the pilot has to be an approved license pilot.
No, even sports license cannot carry passenger. Sport license cannot on your own.
Oh, means you need a commercial license, really. Yeah.
You need a full-fledged license to carry passenger. No, what your? Yeah. Of course, I bring my wife up lah. I mean, before she become my wife. But I think we probably, in this case, we probably are not going down that route of what Volocopter is doing, right? Is now they want to commercialize, they need a pilot to fetch. All right, how many people can be trained to become a pilot? Okay, training to become a pilot is not as simple as just fly. There are air law, there's some theory paper to get you intensely full-time 6 months. That was one year, Yeah, correct. Colorblind only cannot fly. But this one, there's no medical fitness thing. Colorblind also can fly. But not in Singapore, in US. You go to US, you can fly. So I think the path to go, if you have 2-seater, will be autonomous. That will be 10 years later, I think. That means when, frankly, what I look at is, we fly in US, and then US say, okay, you can now fly autonomous. If the craft is okay, fly autonomous. Once you fly autonomous, then you come back to Singapore, then you see us. Okay, let's see it for 5 years. Oh, okay, can. Then we start. It will happen slowly. Yeah, but having 2-seater, we have to change our business model quite a bit. And when we change our business model quite a bit, having 2 or 3-seater means we are going to fight with 10 years later, Airbus, which is not something I want to go. Airbus will not come and fight with tourism. Airbus will still maintain their transport mechanism, right? They won't come in and do tourism. It's too low end for them. I mean, I spoke to them. Then I say that, oh, when is this type of thing going to fly? You say, 10 years later. Why? Because they got to be 99.9999% sure it's safe. We don't need. No. It's not. They will certify it according to commercial airline standard. We certify to ultralight standard, which is completely different in design, in testing, in airworthiness, in different approach. Completely different. Doesn't mean we are not safe, lah. Yeah. But the testing is tremendous, you know. Their kind of testing will cost you $20–30 million. Yeah.
Okay, technical question. Actually, I'm kind of curious. When you're doing this drone, when you're designing this drone, right, where do you guys learn about the prop size, the power ratio, the speed?
That's what university is for, right? You study aeronautical engineering. Sorry? Yeah.
No.
No.
So for propulsion, all these, we actually collaborated with a company called T-Moto. We have heard of them. They are one of the biggest propulsion for UAV motors in the world. Yeah. So what me and my team did was we had to calculate the different type of motor type, the winding, all the technical type of stuff. We give the specification to them, then they manufacture for us. Yeah. So in terms of like the propeller, all these all are customized. So each one of them, the core is more than enough to strap a turkey if the turkey flying. Yeah. So all these are very strong. Yeah. And then in terms of like for manufacturing all these, we do have manufacturers that specialize in composite materials. They are overseas, are not in Singapore. Yeah. We do check with the Singapore market, but I would say the price and the experience is still not there for us yet. Yeah, correct. Because when we give them our specification, the thing will be done within 1 to 2 months to our specification. Yeah, whereas some, when we approach them, some will take like 6 months because they have never done something like this before. Yeah, correct. And then that 6 months out is still a prototype. It's not a finished product yet. Yeah, correct. So those back then, yeah, things, the timeline that we have was very tight. It's not something that we can afford. Yeah, correct.
Yeah, so it depends on how we train our students, right? So if you look at this, right, and in Singapore, most of our trainings are MRO, right? Maintenance, repair, and overhaul, which is the aircraft comes in and they just need to repair. So a lot of poly students or the poly diploma courses incorporate what they call licensed aircraft engineer. You get a license to maintain the aircraft, all right? So you don't have people who are designing new aircraft because there's no such industry here. In fact, if you go to CAS and ask for guidance on designing new aircraft, they say don't have. Why? MRO a lot. How to repair aircraft, we can certified license you. But you want to build a new aircraft, we don't have SOP. See, but because all the while we never build aircraft here, we never have a culture, right? Or industry. So therefore you just have to have a group of people who dare to try and work differently from the current industry. You bring a repair, maintenance, overhaul engineers to come and design this, I will think it will be disaster because they'll start applying that maintaining of SIA aircraft quality inside here, and you will be over designed, right? Because remember, this is 125 kilograms. You didn't know, right? You look at this thing, looks damn heavy, right? It's super light, you know. It's actually very difficult to design. You need a lot of ingenuity and applying of all your science knowledge to trade off a lot of things. So frankly, we don't have this type of people, but no, just try lah, build something and see whether it works or not. Okay.
What is the cost of doing this one?
Cost? Yeah. What's the parts cost?
Huh?
What's the parts cost? This one, yeah.
Less than half a mil.
Huh?
Less than half a mil. I think.
Less than what?
Less than half a mil.
How much?
Less than 500K.
100 ah?
500.
Less than 500.
The cost.
Total
for this
cost.
one.
Oh. I think the prototyping parts.
This is a prototyping cost that is an expensive one.
Yeah.
Where in terms of production, I think it's less than 100,000.
Yeah.
Yeah.
I think each one about parts, just parts alone, about 190 to 200K, about 200K plus parts. Because you are buying customized thing, everything off the shelf, one time only, so it's expensive. Yeah. And we built two. Sorry? You want to tell? What kind of improvement?
Yes, correct. Battery. Yeah, actually battery still not as much. It's more on the propulsion system. Yeah, correct. Because the current type of propulsion system is efficient, but it gets hot very fast. So the new one that we are developing has active like water cooling inside the system itself. So we can run it much more higher, but at the same time make it more efficient. Yeah. Then we are also coming out with a new blade design as well. Yeah. In terms of chassis, we are still deciding what type to go for, whether to stick with a composite one or more like a roll cage type of structure. Yeah, because ultimately you want something that is able to do the production fast. Because this one, although is very light also, but when in terms of assembling all this is still quite complex. Yeah.
So for the new craft, we have not really fully decide how are we going to engage the public. Usually what we do is we design already, then at air show, we show everybody. But we may change. The concept is to maybe engage the public so that when we design, we will have we will record it straight away. That means we will time lapse it, so that hopefully every week we do something. We show something. Time lapse week. There's this whole new thing of fundraising. I'm actually exploring NFT, so that we have different pictures. Yeah, then we raise fund along the way, right? Yeah. So haven't fully figured out, but those are the concept of having time-lapse video to show what's happening, and in the meantime we explore what are options at NFT to engage the world. So whether we will engage students or not, of course when they do designing, we probably will not. We will have interns for sure, those who are engineering type. But the general public, maybe you want to suggest how you want to participate, then we can consider. Because we don't know what you want. You can say, yeah, we would like to pop in once a while, every quarter just to see, or you based on the NFT shoot some question, not NFT, time lapse shoot some questions. We don't know, but our target is April we start, the next generation. Logo? Not now, not now. Unless it's our investor, then no choice. We do have investors who want to put logo, and I say, yeah, you can, but when it's appropriate. Yeah. But unless you invest, then you can detect me, right? Yeah. It's sponsor, if you give a lot of money, also can. Yeah. So think about it, there are a couple of ways to engage, right? One is bring this craft and let the student dream or talk about it, interest them. And we have the glider course, which I think you have also. We have the glider course, we have the drone course, which you can use. Then the other way is when we are building the new version, you can keep track.
Just a really quick one. I'm going to take 5 minutes, okay? Basically, to share with you guys, I think earlier on you also mentioned that what Neo Aeronautics do is we partner with Science Center together with SIT to promote STEM activities to the students. So there's actually 6 main focus for 2022. The theme this year is Space Expedition. Okay, so first up, the first activities that we actually focus on in 2022 is Space Exploration Journey. You don't have to take pictures, so what we will do is we'll give you guys the flyer to take back together with you to share with the students. Okay, so for Space Exploration Journey, what we want the students to think about is what are some of the opportunities that space can bring to them, you know, and come up with a mission to the moon and design a moon rover to explore the moon. So for this space exploration journey, it has already ended in Feb lah. So even if students want to participate now, it's currently closed, but there's still other activities that secondary school students can participate in. Okay, second activity that we focus on is the Space Tech Hackathons. This is actually open to IHL. Okay, so what we basically do is we partner with polys and universities to launch these space hackathons. The theme will revolve around space. So I'll give you one example that SIT is actually doing. So the theme for the students in SIT is to innovate some of the technologies that they can use with 3D printing to live sustainably in space. Okay. Next up would be the Space Sci-Fi Writing Contest. So this one will be open to secondary school students, all level, across secondary school. So what we want the students to do, you know, is to think creatively. What is it like living in space, you know, and come up with a fiction story about what they have in mind. It's going to be about 300 to 500 word limit. So for this Space Sci-Fi Contest, we actually have a video workshop that is on our YouTube channel and on our website. We also have the PDF workshop materials. So if the teachers are actually interested to share with their students, they can actually use these resources on our website. Okay, we also have a flyer created, which we will give you the hard copy later on. So we're going to select 15 winners. So for top 3 prizes, right, it's $500 cash. 4th to 13 prizes onwards, 13 winners, 4th to 13 prizes onwards is $300 cash each. Okay, so last week we just added one more subcategory for this Space Sci-Fi Contest. What we're going to do is, we call it the Space Sci-Fi Pictorial Writing. So this is actually open to lower secondary school students and also primary school, mainly because it's going to be so much easier. So what we want them to think about is, you know, what are some of the problems or challenges faced living in space? And then we want them to think about a solution. Doesn't matter if it's like, you know, it may not work now, but in future, like let's say maybe 2030, 2040, we may have technologies available to help them with this solution that they came up with. So what we want them to do is basically to write a story, a short story using the design thinking framework. Okay, so there are basically like 4 steps. First would be for them to come up with a persona. Okay, then they think about one of the problems that they face in space, come up with a solution, and then tell us about the user experience based on the solution that they have invented or they have created. Okay, so these are some of the things that you guys can take back to your school and share with the students. Okay, so that is for Space Sci-Fi Contest. Next up will be Rocket Blast Off. So Rocket Blast Off again is open to secondary school students and IHL. So what we will do is we will actually select and shortlist a few students for Rocket Blast Off. So we're currently still fine-tuning some of the details. If let's say you have any students who's interested in this Rocket Blast Off mission, you can go to our website to register your interest. Okay, 5th activity is on space innovation discovery. This is mainly to invite entrepreneurs or Singapore startup to discover how we can actually use their technologies in space and to generate space ventures. Okay. Last activity would be the Space RIE Week. So RIE stands for Research, Innovation and Entrepreneurship. So what is going to happen here in this Space RIE Week? We're going to invite NASA astronaut Jeff Williams to come to Singapore physically. So what Jeff will do is Jeff will actually visit the schools. So we have schools that participated in the space hackathons, the polys and universities. So he will visit those schools, and students whose project or prototypes or ideas are being shortlisted will actually present to Jeff and see, what are some of the ideas that he can bring it up to, NASA or possible ventures into space. Okay, Jeff will also make a public appearance at Science Center that week. So if you're interested, it's going to be on the week of 8 June. Okay, more details will be announced on our website once it's confirmed. Okay, so that's all I have about the activities that we'll be sharing in 2022. We will distribute out the flyers in a bit. Okay, so I'll pass back the time to you, Hok.